All right. Never mind. I made a mistake. We're not going to take notes because you already took notes on this. Just a quick review from the notes that you already took. And then we're going to do the next set of problems. So we did this example problem in class already, but I just want to go over it again. If I give you 60% of carbon, 13.4% hydrogen, 26.6% oxygen, you're going to find the percent composition, or sorry, you're going to find the empirical formula from this, which is percent composition. So with those numbers, 6%, 13.4%, 26.6%, we're going to make that all equal to grams, because if that's 100% total, which all percentages add up to 100%, if we make it 100 grams, then if the total is 100 grams, then 6% of 100 grams is 60 grams. 13.4% of 100 grams is 13.4 grams. 26.6% of 100 grams is 26 grams. So skipping through all of this, because the book wants you to do percentages and numbers, I'm simply just saying you guys are smart enough to see that 60 grams goes to, or 60% goes to 60 grams, 13.4% goes to 13.4 grams, 26.6% goes to 26.6 grams. We don't have to do all the extra percentages and decimals and stuff like that. All right, so once you have those, you change your percentages into grams. Then we're going to convert grams to moles like we've done before. So 60 grams of carbon equals how many moles of carbon? 13.4 grams of hydrogen equals how many moles? So we've done those calculations before. Let me just remind you. So if I have 60 grams of carbon, I know that according to periodic table, actually let me just draw it up here for you since you probably don't have it. Carbon 6, 12, that's horrible. Look at 12, that looks like 18. I'm just getting rid of all that. For hydrogen, we know hydrogen is 1 and 1. Oxygen is 8 and 16. So that's where you get those numbers from. For carbon, we're looking up carbon, 60 grams of carbon. What is the molar mass of carbon? 12. 60 grams over 12 grams. Got the moles there. For hydrogen, same thing. We got hydrogen, 13.4 grams of hydrogen. Big number of hydrogen is 1. So 13.3. I don't know. Yeah, that 0.01. Yeah. 13.3. If you put 13.4, it doesn't really change anything anyway. For oxygen, if I got 26.6% oxygen, 26.6 grams of oxygen. Now we can say 26.6 grams divided by 16 comes from that number. Equals 1.66 moles of oxygen. Once you have moles of everything, carbon, hydrogen, oxygen, for this problem, you're going to convert that into, or you're going to take the lowest amount of moles, divide everything by that. So 1.66 moles of oxygen is the lowest. You're going to divide 5 by that number, 13.3 by the number, and 1.66 obviously by itself. And then you'll get a molar ratio, 3 for carbon, 8 for hydrogen, and 1 for oxygen, which leads you to C3H8O. And we did this in class already. Just a quick refresher. So, practice problem number 11. Assume that you have a 100 gram sample of this liquid, as we talked about. So I have 9.2% boron, which I'm going to say is 9.2 grams of boron. Then I have 90.8% chlorine. We're going to change that to 90.8 grams of chlorine. Good. Looks neater when you type it. Now we're going to convert each mass into moles. So we have 9.2 grams of boron, my third favorite element. I know that boron is 11 grams equals to 1 mole. And 9.2 divided by 11, that is some number. I don't know. Off the top of my head. I'm guessing it's like 0.8 something. I'll figure it out in a minute. Anyway, now I have 90.8 grams of chlorine. According to the periodic table, which I have up there. I know that chlorine is 35 grams per mole. 90.8 divided by 35. 2.2. 2.3 is my guess. Let's see how close I am. Dang. It's not bad. I was really close on the 0.85. What did I say, 0.85? Is that, I said 0.8 or something like that? 0.9? 0.8? Anyway. Yeah, I wasn't close. I said 2.3, 2.2. Yeah, I was close. 2.5. Anyway. So those are your moles. So you got 0.85 moles of boron, 2.56 moles of chlorine. Then once you have moles, you divide it by the lowest moles, which is 0.85. So you divide boron by 0.85. And then, but you also divide chlorine by 0.85. And then that is, of course, boron is going to equal 1. And chlorine is going to equal 2. I'm saying 3. I'm going with 3. So it's going to be BCl3 is what I'm going to go out on a limb and say without looking at my numbers. That is good. Perfect. Oh, okay. Keeps going. Okay. BCl3. That's for number 11. Number 12. Determine empirical formula for 50.1% sulfur and 49.9% oxygen. Of course, going to turn those percentages into grams. So 50.1 grams of sulfur, 49.9 grams of oxygen. Once you have grams, convert grams into moles. Just going to get rid of that, make some more room. Let me use a different color too. So for sulfur, I've got 50.1 grams of sulfur. Each sulfur is 32 grams according to the periodic table. I'm going to say 1.3. Guessing. For 49.9 grams of oxygen. Again, oxygen is 16 grams per mole, again, according to those numbers up there. And let's see, I'm going to go with 3.2. No, 3.1. Let's go 3.1. Let's see how close I am. Wow. I said 1.3. Okay, I was low in there. But 3.1, I'm really good at. 3.1, I'm really close on. Anyway, 1.67 moles for sulfur, 3.12 moles of oxygen. Divide each one by 1.67. I'm sorry, I'm writing sloppy. I blame COVID. Anyway, that looks like, of course, sulfur is going to be 1. Oxygen looks like it's going to be 2. So SO2 is what I'm thinking. I'm pretty sure about that one. Hey, 1.87 is... Really? I thought it should be close enough. But anyway, 1.87, close enough. It's SO2.